All set? Any questions? No questions. Okay. So let's start with a recap, okay? So we define a function exponential of x as limit and tending to infinity of 1 plus x over n to the n. Okay? And then we also saw that we have a series representation of this exponential function, okay, which is 1 plus x plus 1 over 2 factorial x square plus 1 over 3 factorial x cube and so forth. We also introduced a number which is called e, okay, which is 1. So you put x equal to 1 in here, that is e. Okay, and e turned out to be approximately 2.7. Is that correct? 2.7 something? Okay, so that is 2.7 and approximately, okay, it's a transcendental function, a transcendental number. So, okay. So I will now work with this expansion and we'll derive some nice, did I say niceful? I wanted to say useful and nice together, so I said niceful. Useful results. And I think सबसे पहले, let's see, yeah, this is the one. So, okay, what is e to the y? E to the y is the same expression with x replaced by y, right? Sorry, I cannot use this notation. I have not told you what this is. Sorry, I am sorry. So let's look at, so I'll take this function exponential x, okay, and take another function exponential y. What is exponential y? It is 1 plus y square over 2 factorial and so forth, okay, and I multiply these two. So let us look at exponential of x times exponential of y, okay, where x and y are two variables. Fine. Let's evaluate this. What is exponential of x? That is 1 plus x square over. Am I doing the same thing which I, yes, that's what I want to do. Okay, so they are infinite terms times 1 plus y okay. Do you enjoy multiplication? Because this is the time to, no, you don't? Okay, so we'll enjoy together. So let's multiply this, okay. Now again, the way we were thinking earlier, that's we are not going to just start multiply this and that. That's not how we'll do. We'll do the same thing, but in this way. When you multiply any polynomial, right now this is not a polynomial, it's an infinite thing, okay, but suppose I stopped at some level. If I multiply that polynomial with another polynomial, each term will have some degree. So there will be terms of degree 0, terms of degree 1, terms of degree 2, 3 and so forth. So degree 1 term, let's say degree 2 term, a term of degree 2 can be of the following forms. It could have x square, that's a degree 2, or y square, or x times y. Okay, these are the all possible ways in which you can have a degree 2 term. So we will do it that way. So let's first write down degree 0 term. What is that? 1. Then degree 1. In how many ways you can generate degree 1 terms? If you multiply x here with 1 that produces a degree 1 term. If you multiply y here with that one, it produces a degree 1 term. So you get x plus y. Now let's generate degree. So that's degree. These are all degree 1 terms. Let's generate degree 2 terms. So what are all possible ways in which you can generate? If you look here, if you take x square term and multiply with 1, that's one way. Y square term, multiply with that one, that's another way. Or if you take x here and y there, the product is a degree 2 term. Is that okay? So let's write it down. So x square over 2 factorial multiplied by 1 is x square over 2 factorial plus y square over 2 factorial multiplied with this one is y square over 2 factorial. And now magic starts happening. Multiply x with y and it is xy. I mean, there's no magic in having xy, but soon you'll see in a moment. Agreed? Can you see something more? Do you see the magic?
I think so.
You think so? Very good. So
Rationalize the denominator.
yes, hold on. Good, you see that. Let's look at degree 3 term now. So if you start just multiplying randomly, you will not see them. You organize it nicely. You have noticed something. Very good. Let's look at degree 3 term. This times this. So that is one way. Y cube times 1, that's another way. X square times y, that's a degree 3 term. Y square times x, that's another degree 3 term. Anything else? Nothing. I hope I have said everything. Let's write down. So you get x cube over 3 factorial plus y cube over 3 factorial. Okay. Then x square into y, x square over 2 factorial into y plus y square over 2 factorial into x. Is there anything else? There is nothing else. These are all the terms. Similarly, you can write degree 4 term, degree 5 term, degree n term, degree whatever terms. Okay, so very good. So this says 1 plus x plus y plus. Now look here. 2 factorial is 2, right? 2 factorial is 1 times 2, that's 2. Multiply and divide by 2. The 2 in the denominator you can write as 2 factorial. Pull that 1 over 2 factorial common, so you'll have a 2 left here, right? So you have 1 over 2 factorial times x square plus y square plus 2xy. But x square plus y square plus 2xy is x plus y whole square. That's nice. That's such a nice thing happening, right? Okay, let's look at this one. Let's multiply. Okay, let's multiply by and divide by 3. So 3 x square y over 3 into 2 factorial. But 3 into 2 factorial is 3 factorial, right? See, 3 factorial, 3 into 2 into 1 is 3 factorial. 3 into, what is 2 into 1? It's 2 factorial. So 3 into 2 factorial is 3 factorial. Agreed? So multiply and divide by 3. That gives you 3 factorial in denominator, 3 in the numerator. Similarly here, and I pull out a 3 factorial. 1 over 3 factorial. So 1 over 3 factorial, x cube plus y cube plus 3x square y plus 3x y square. What is that?
X plus y cube.
X plus y cube. See, Papa is a better student. Okay? Is that okay? Now you see the magic part. The magic is this. if I look at exponential of x, that is 1 plus x plus this is. If instead of exponential of x, if I had written exponential of x plus y is z, right? Let's say exponential of z. Exponential of z is 1 plus z square over 2 factorial and so forth. Let's say z is equal to x plus y, then it will become 1 plus x plus y whole square over 2 factorial. That's what you have. Okay, I have not, it might be that, okay, we were lucky with first few terms, it doesn't work for other ones, but that's an homework. That's a homework, you can check. It will work for each term. So, which means, cube, correct. Okay, so what we see is this is equal to exponential of x plus y. Okay, that's a nice thing. That's a very nice, interesting thing to know. Exponential of x times exponential of y is exponential of x plus y. This is unexpected actually. See, sine of x times sine of y is not sine of x plus y. Sine of 10 degrees plus sine of into sine of 10 degrees is not equal to sine of 20 degrees, right? Or x into y is not equal to x plus y. But exponential of x into exponential of y is exponential of x plus y. Okay, that's a nice result. Any questions? So I have shown you a nice thing, which is exponential of x times exponential of y is equal to, is it captured in the camera or is it out of the frame?
It's there.
It's there. Okay, very good. So let's take y equal to minus x. X is a real number, any real number, right? X is any variable, so any real number you can take.
0.
Let's say x equal to, x, if you take 0, you know what it is.
No,
It is 1. Okay, also we have seen, now since you said that, I will write it down. Exponential of 0 is? Exponential of 0 is? 1, very good. You can speak, no, why you do this? You can directly tell the answer. Exponential of 0 is 1, okay? Now I will use this result to get something nice. Let's take y equal to minus x, okay? Take y equal to minus x and put y equal to minus x in exponential of x times exponential of y is equal to exponential of x plus y. Oh my goodness, too much beauty. If I put y equal to minus x, then I get exponential of x times, let me put this one first, okay? Is this fine? It looks cluttered, I don't like it. Exponential of minus x times exponential of x is equal to x
Exponential
minus x here, I mean you can put this factor first, right, it doesn't matter, is equal to exponential of minus x plus x, right, is equal to exponential of 0, but exponential of 0 is 1.
1.
Beautiful. Which means something interesting. It means if I divide both sides, see, exponential of x is some number. To choose an x, you get some value. Choose x equal to 1, you get e. Choose x equal to 500, you will get another number. Take exponential of x and divide the entire equation by exponential of x. Right? If I divide the entire exponential equation by exponential of x, then I get on the left hand side exponential of minus x. This is divided, so that gives you 1 is equal to isn't that nice? right? Sine of minus x is not equal to 1 over sine x. Minus x whole squared is not equal to minus x whole squared is not equal to 1 over minus x whole square. But exponential of minus x is equal to 1 over exponential of x. Okay? Good. Now, what are you doing?
I'm trying that with some value.
Okay, you can do that later. Okay? So you see this is a good result, right? It is telling you many other things. Now how about this? So I will put this in a nice box. That's a nice result. Now let's play a little more. So let's take exponential of x over 2. So some x you chose, take half of it. Okay? Exponential of x over 2 times exponential of x over 2. Using this result, what do you get? That is exponential of
X.
whatever this number is. See here, whatever this number is the same number. So it's a square of this. Square of this. If x square is equal to 4, then x is equal to square root of 4 or plus minus square root of 4. Right? Correct? So this says that exponential of x over 2 is equal to Is it okay? So if you are given a function exponential of x and you want to take square root of 2, then all you have to do is just divide the argument by 2. If you have to take the square root of exponential of x, just divide the argument by 2. Okay?
Dividing exponential of x over 3 will not be cubed.
Dividing by 3 will not be cube root or not. Okay, let's check. So you are asking whether this is true. This is what you are asking, right? Okay, let's see. Exponential of x over 3 into exponential of x over 3 into exponential of x over 3 is equal to, let us use the result exponential of x times exponential of y is equal to exponential of x plus y. So first you use on these two terms, these two factors. Okay? So what does that become? This becomes exponential of 2x over 3. And what is this? This is still there, right? But what is this? Again you use the same result. Now it becomes exponential of x over 3 plus 2x over 3. That is 3x over 3. This is x. Meaning, whatever that number is, let's call it z. Z into z into z. Z cube is equal to this. So z is cube root of that, which means your guess or something which you are not guessing was true. So exponential of x over 3 is equal to exponential of x is okay. Now there is something which you should have asked me here. If x square is equal to 4, then x is equal to plus minus root 4, right? Or which is plus minus 2. Here I did not write the other one. I didn't say, okay, there is plus minus. Okay, we'll come back to that later, but that you should have asked. You should have immediately drawn your swords. No, that's not correct. Right? You didn't take out your sword. Both should be possible. We have not talked about another. Why not? It should be there, right? So I'll tell you later. Remind me if I don't. Maybe at some point it will get covered. But any guess?
Exponential functions can only be positive.
Yes. That would explain. Good guess. Okay, so what? So why only cube roots? Any root, right? So if I take exponential of x over some q, okay? What are you doing? Okay, q is some integer. Okay, so let's say q is some integer. So q is any integer, any positive integer. Multiply it q times. Then this will be again using that rule that exponential of x times exponential of y is exponential of x plus y. Repeatedly you will arrive at, like before, exponential of, this is a bit weird, exponential of x over q plus x over q plus x over q q times, right? Which is qx over q, which is x. So I have exponential of x over q, where q is some integer, positive integer I am taking, is equal to exponential of x to the power 1 over q. Agreed? Another interesting thing, another nice result. I have already shown you that exponential of minus x is inverse of exponential of x, 1 over exponential of x. Let's use that. So let's say exponential of minus x over q. So I put a minus sign. So I take x instead of x minus x. So it becomes, this becomes 1 over exponential of x. Right? Wherever you have x, put minus x. But exponential of minus x is 1 over exponential of x.
Exponential of x to the power q.
Sorry?
Exponential of x to the power q.
No. 1 over, no? No, to the. This is fine. What is the problem? I have put x equal. This was okay?
Yeah, this is correct, but you can also write this as e to the power x. Sorry, exponential of x to the power q.
No.
You cannot?
No. Okay. Now comes the nice part. Okay. So, if you have exponential of x, what do I want to do?
Oh, okay, never mind. I was thinking something else.
Just a second. Okay.
-1.
So let's take, okay. So what do I have? What have I shown so far? So I have shown you many things. One is exponential of x whole square is how much? No. This is exponential of x into exponential of x. So it is exponential of 2x. Right? So exponential of x raised to the power p is exponential of px, where p is some integer. Okay? Exponential of q, sorry, I'm losing the thread a bit. Did I say? Huh. So then let's look at this. What is exponential of x power 1 over q? You remember here? Exponential of 1 over q is exponential of x over q, right? Exponential x to the power 1 over q is exponential of x over q. So now let's look at this. Imagine alpha is some rational number. Okay, alpha is some rational number which can be written in the form of p over q, where q is not equal to 0. Right? If it's a rational number, then you can write it as a ratio of two integers where q is not equal to 0. Okay? So let's take some alpha, whatever alpha you like. And then correspondingly find p and q where q is not equal to 0. Let's say that p is this p, that q is that q. So exponential of alpha x is equal to exponential of p over qx is equal to exponential of you can see that from this it will be exponential of x to the power can you see that? Because this I can write as exponential of 1 over q x plus 1 over qx plus 1 over qx p times. Okay, maybe I'll do it in 2 steps. Is that okay? So it will give you exponential of x over q to the power p. But then I use this result to write this. But what is p over q? That is alpha. That's an important result. For any rational number alpha, why are you getting distracted? For any rational number alpha, exponential of x raised to that power is simply exponential of x times alpha. Right? Now, any irrational number can be approximated by a rational number as closely as you wish. Right? So if you have pi is 22 over 7 approximately. Right? But if you want a better approximation, you can construct another rational number which will be, take the value of pi, stop it at whatever decimal place you want. That's the rational number. You can always write that in form of P over Q. Okay, so which means that, okay, other than irrational numbers, for rational numbers this is true, for any rational number, and for irrational number you can be as close as you wish, and this will work. And you can define that my function is such that even for irrational number this is true, and that makes sense because you can approximate it as close as you wish to an irrational number, and it works that way. Okay, so we have this important result that exponential of x raised to the power alpha, where alpha is any real number now, is equal to exponential of alpha x. Agreed? We are almost there to see something beautiful. Now alpha is nice, alpha. I just want to write it as y. I mean, you can write alpha, there is no problem. I just feel like writing y, so I will write y. So let's write alpha as y. So this is saying exponential of x raised to some y, where y you can choose whatever you want it to be, is same as exponential of y times x. Now let's choose x. You realize you have understood, you realize something, good. What? Your mouse opened this big. Now, yeah, tell me what I should do. Put
x equal to 1.
Beautiful, beautiful, beautiful. Put x is equal to 1, and that makes it exponential of 1 raised to the power y is equal to exponential of y. Okay, but exponential of 1 is e. That's the number e. E to the y, e raised to the power y. That is e times e times e if y is a positive integer, but whatever. E to the y is exponential of y. If you don't like y, you like x, it's saying exponential of x is equal to e to the x. That function is really a number e raised to x. Now I can use, you understand how just that one thing, limit 1 plus x over n raised to the n going to infinity, that was our starting point. We have not assumed anything. It all came out of it. So the thing is, you should understand, just I could not have started by saying 1 plus x over n raised to the n is e to the x. That makes no sense. Okay, let me emphasize this point in a beautiful way. By beautiful I meant neat way. See, I just want to clarify, okay, it might be not so obvious, that if you have, when we started this, we said exponential of x is defined to be okay. You might think, okay, here itself I should have written e to the x, but there is no reason for me to write that way, right? Because if I write that, I am already assuming that it is some number to the power something. That I cannot do, because, for example, 2 to the x times 2 to the y, it's built in the notation that it is 2 times x plus y. But I cannot assume those things here. But now I have proved that indeed that is, and in fact I got that expression. Okay? So what I was doing in between was all these things. If you go back and see, 2 to the x times 2 to the y is 2 to the, these things, right? So, any questions? Tired? No, I think you're excited. Good? Happy? Okay, so we'll stop here. Shall we stop or shall we record more? So let's stop here and we will continue from here next time.